Welcome, welcome to Understanding Microservices, a guide for the monolithic developer. Yay! We got another slide. I'm hoping this will get faster. I'm Layla, and I was a monolithic developer for a very, very long time. And then I started at my job where it's distribute all the things, and all my colleagues are Spring developers, and everything's everywhere. So I started to learn about microservices when I joined VMware. I'm all these things, but mostly an educator. I love sharing knowledge, so that's why I'm stood up here. So let's have a little think about why you might be here. It's probably because you've been to endless talks where they're like, microservices, you must do them. They're awesome. They're fantastic. Go and do some microservices. And you're like, yeah, okay, that sounds fun. That would look good on my resume. Or your CTO has said, I've heard about this thing called microservices, and I think we should do them. And you're like, well, there's only 5 of us on the team, but I guess maybe we can manage. So you've gone through all of this. I'm not going to tell you why you should have microservices. This is the next step. We've got some hands up at the back, that was you, okay, I'm hoping, okay, I'm confused. Never mind, I'm going to keep going. So you have decided. Now, I am going to ask you one question, okay? Are you sure? All right? This is a really important question. If you cannot answer yes to this, you are not ready to go to microservices. Okay, I lied. I'm going to ask you another question. Are you sure you're sure? Okay? Because this is really important. When you embark down this route, it's not going to be fun and games and kittens and rainbows, okay? It's tough, all right? But I'm going to try and help you on your journey to microservices. All right. So you have definitely decided you need microservices. You're sure. You're sure you're sure. And you're moving on. So there's a whole load of stuff that comes in now. What is all this gobbledygook? Now, that is a British word, gobbledygook. I've taught you a new word now. It's unintelligible words that you don't know what they mean. They sound weird. They sound like other words. There's a whole load of those when you come into this ecosystem, okay? It's gobbledygook. Where do you start? It's really confusing to think, well, I've got this monolith, it's all self-contained. How do I go from this to stuff everywhere, doing lots of different things, okay? And how do you even go about creating that proof of concept? You don't want to just dive straight in. You want to do some proofs of concept and play a little bit first, okay? So a big thing is where to begin. And this is really dependent on you and your company and your team. Are you going to refactor? Is it a fresh start? How are you going to go about doing this? And that's a very personal in team, not you as a person, journey, that you'll have to look at all the different things, okay, that you need to do and what you want to get out of this distributed system. But this is the main thing. You're doing it incrementally, okay? This is what I want you to really embrace. We're going to do this incrementally. So one step at a time, all right? This is so vital in this process. You're going to do a little incremental change, test it, explore it, make sure it's the right step, rinse and repeat, okay? That's really vital. Let's start with a glossary of common terms then. I said about it being gobbledygook, and these are not strictly to do with microservices. You'll know some of these from your regular cloud development. And we're going to go into some of these in a little more detail as well. So service registry is something you'll hear, and this is how applications locate themselves. Load balancers, you're probably familiar with. They're a common sort of front to your applications, and especially if you've maybe got 2 instances running, you'll have a load balancer to route your traffic. Circuit breakers, so if you are looking into resiliency in your applications, perhaps you've had a play with poly policies. If you haven't, they are fantastic, and you can circuit break all the things, not just HTTP, but all of your dodgy code, so your database access code, all of that. You can go and get that, okay? So that's a really good thing. I've got whole other talks on that, but we're not really going to touch into that too much. API gateways, they are a single unified front for all of your traffic to come through to your back-end services. I will cover those in a little bit more depth. External configuration, this is really, really important. This is taking all of your configuration out of your applications and putting them in a centralized place. This means that you can update them live, that all your instances share the same configuration. You can share configuration across different applications. So this is a really interesting thing that you should definitely look into. And then the bounded context. This is the sort of edges of each microservice where they have commonalities, okay? So if you have one service wanting to speak to another service, they need to have a common language. So this is your context. So if you're in the keynote this morning, it's kind of like that. Our applications need to have context of each other in a common language. Okay, so I like to give examples. And they're generally food-related. I'm a fan of food. I hope you all are too. And this is Tacky Tacos. It's one of my favorite companies. So it is an e-commerce food ordering site. Things go crazy on a Tuesday for Taco Tuesday, and they want to scale to meet business demand. They also want to easily add in new services like order tracking. Oh, my voice just got deeper. Wow, okay. So we're going to look at that, and this is going to help give you context to understand some of these things a little bit better. So this is our monolith. This is probably very familiar. I'm not going to go into your architectures. I don't really mind what architecture you have. You might be doing DDD, you might just be doing N-tier or clean or hexagonal or onion or any of those things. I don't care. The principles are the same, okay? So we're going to look at this. This is just an N-tier. This is usual types of things that your application might have. So how do we go about decomposing, that's what we'll call it, to take this monolith into individual things, your little microservices. Okay, so we have this chart. I stole this from a teammate who stole it from someone else, who stole it from someone else. So I don't know who this actually belongs to, but it's mine now, okay? As in, like, ownership is 9/10, yeah? So it is mine, and let's just say the big ball of mud in the bottom left-hand corner is probably your monolith. Now, I don't like to tarnish monoliths. I'm a big fan of the monolith. It is so easy to work with. It's easy to debug and deploy and all of these things and secure. But they can get messy. As we add more features into them, they can become more tangled. You may say that's spaghetti code, but a common idea is this big ball of mud. It's all mushed together, all entangled. You don't really know what you have and what you can do. And you want to go here, okay? So that seems a pretty big leap to go from this mush of unintelligible, mixed-up code to distributed systems, okay? Now, you think, that's why it says you think you need to go here to microservices. That's your end goal, but it's not the path you want to take. Because if you go straight to microservices, you're going to end up with the distributed big ball of mud. You do not want to go to the top left. You do not want to go there. A distributed big ball of mud has none of the ease of the monolith. It has all of the bad stuff of the monolith, and it has all of the complexity and difficulty of a distributed system with none of the benefits. Okay, so this is bad. You do not want to be up there, and it is so easy to end up there, okay? Instead, you want to go the modular monolith and up to microservices, okay? So this is the happy path. You will be much happier if you go this route, okay? So I like to think of this as the Kit Kat pattern. This is my thing. I am trying to make it a thing, okay? So go with me. Now, if you think about modules in a monolith and you compare those to a Kit Kat, okay? This is one chocolate bar. You can't really see it on this screen, but it's one. I hope you're all familiar with a Kit Kat, okay? So it has individual biscuits, and it makes up one big chocolate, okay? So each one of those is a module, okay? And you can snap them off, and you now have two biscuits. They're like miniatures. So I like to think of it as the Kit Kat pattern. I told you I like food. So let's think about each one of these, a biscuit in a Kit Kat. So we have large modules. Now, this is important. You want to make your modules as large as possible to begin with, okay? This is maybe counterintuitive to microservices, but this is how you get the least amount of complexity. You're going to make big chunks because you can further decompose those chunks. So you see we've got an orders one here. Let's say you want to further decompose that. So you can now break those down into smaller modules within there, but you can present that to everything else as one module, okay? So you can start decomposing everything down into smaller things as and when you need it. Remember that rule, incrementally. You're going to break things down as you go along, not just one big thing. So even if you're doing greenfield development, it's a very good exercise to think about this modularization before you go fully distributed, okay? Because it's going to make your life easier. You're going to learn your application's needs more than just theorizing before you've even written it. Okay, so one of these things that you want to really embrace, and I've got this from DDD, but it's not exclusive to that, is the loose coupling and high cohesion. So this is what you want to think about when you are decomposing. So loose coupling means that things don't really have a dependency on each other, okay? They're loosely coupled. And high cohesion means that things that are together are really related. Like orders, everything to do with orders is highly cohesive. And that's very separate from everything to do with, I don't know, payments, okay? That's loosely coupled. They don't need to know each other's personal life. They're just like, oh, we're just going to send some stuff across. So they're loosely coupled, but everything within the module is highly cohesive. So let's think about our modular monolith. We've now got modules for everything in here. That's, say, the way you've chosen. You may choose to do it in a more DDD way or whatever way you want. Remember, I don't care how you architect your application. The principles are the same. So now we've got our Kit Kat. We've got our satellite pattern, okay? Now, DHH calls this the citadel pattern, but I don't think it's as good as the satellite pattern. It doesn't make sense to me. Now remember, we snap off those biscuits off the Kit Kat. Those are now satellites. They are completely self-contained biscuit covered in chocolate. Just like the big one, biscuit covered in chocolate. We've broken those off, and now we've got satellites. So our monolith with satellites. And this is really key to that incremental distribution. So we've still got our modular monolith, but now, because our notification system needs to scale dynamically and independently, we've snapped that off, and it's our satellite. This could be a function, a serverless function, because you're not always going to send out maybe 1,000 emails all the time. So let's say you want to send out a marketing hit to all of your customers, you'll scale that notification service up to meet the demand of something quite time-consuming, like sending emails or sending text messages or processing something. And then when it's no longer needed, you can scale it down to 0, and it's not taking up all of that CPU and memory, blah, blah, blah. So this is a really nice way of snapping those off and learning how all of your distributed systems can come together. You probably already have got your clients, your front-end clients, off on CDN somewhere or whatever, or like a client-side application. You've probably already done this without realizing. So this is your modules with satellites. Okay, so let's talk about scope. Just excuse me, I'll try not to slurp loudly. Yes, that was quite good, wow. Okay, so scope is really important. Now, I want you to think about a food truck. If you go out and have food, let's say tacos, because it's Tacky Tacos, and they are excellent tacos. They are so delicious, okay? And it's your favorite food. But now Tacky Tacos is offering hot dogs. Okay, it's still kind of a taco, isn't it? All right, you've got, like, instead of a bun, a taco shell, you've got a bun. It's kind of a taco, okay, similar. I can see the similarities. Well, now they've got burgers. Well, that's more of a sandwich, okay. Pizza, well, where did they get the oven? Okay. Oh, now they've got noodles and rice and sushi. Who's going to eat the sushi out of this food truck? Anyone? Any takers? No? And then maybe they're going into cake and baking. This is too much scope, okay? There is a golden rule for your modules and your services. They should do one thing and do that one thing well, okay? Now, I don't care how big your microservice is, as long as it's doing its one thing and doing that thing well. It doesn't matter. It can be as big as it needs to be or as small as you need it to be. Because people always say, oh, how big is a microservice? Well, how long is a piece of string? It's what it does and the scope of what it needs to do, okay? So this is another thing that you need to do. Everything needs to be highly cohesive, remember, loosely coupled, and doing just that one thing well. Okay, so let's think about the scope of our services. Now, this is big scope, and remember, we can divvy this up as we go along. So this is kind of a common way that you might do it, and just to think about those scope of the processes that application needs to do. So now that we've got that, if we have all of those individual modules, we can keep scaling all of those instances up to do everything that we need. Everything's individually there, and we can scale it as we need. Okay, so this is really cool. But you've got all of these services now. Another thing, see, that Eli's talk this morning was very good because it's led on to lots of things I want to talk about, communication. And if you've got all of these services, how do they communicate? So there's two ways, and the first we're going to look at is synchronous. Now, I don't want you to be confused with asynchronous code, where you do like async await. If you wanted to talk about that, you need to go to Brandon's talk right now, but don't, because you want to stay here and listen to me. We're talking about the process of request response. So HTTP, gRPC, SignalR or WebSockets, TCP, all of these things are considered synchronous. You send a request, you expect a response, okay? You have this two-way communication. Now, I would say that you want to do this for anything that is customer-facing. You, as a human, want that response now. You want that two-way communication. So these are all synchronous communications. So you really want to think about who needs information right now, and that's your customer, okay? Now, asynchronous communication, the other way, is queues and buses. So queues one-to-one, they're not as flexible. Buses are one-to-many. So they're basically the same, but you're going to generally be working with service buses. Now, these are asynchronous because they're not, I mean, they do, but they don't, for the purposes of this. They don't expect a response. If something says, here is some information, it throws it out into the ether. It does not care who comes along and reads that bit of information or who needs it. It doesn't need anything there. It's fire and forget. It doesn't care, okay? So this is why it's asynchronous, because the other side will get that information when they are ready. And that's why it's so key in your distributed systems. So this is how it works. You have a producer. Now, a producer can also be a consumer. So a producer will make that message and enqueue it onto your message queue. Then in its own time, the consumer will come along and dequeue it. So this is fantastic for scaling, for resiliency. So as much of your application as you can should be communicating asynchronously. It's going to really help your systems to be more resilient, better scaled, and just be able to deal with the weight of traffic a lot more. Now, you can do asynchronous communication within your modular monolith as well, because you remember, if you think about that Kit Kat, the biscuit inside is all of your information. There's no biscuit touching other biscuit in another module, so there's no code talking to other code in your module, so you need to do that by asynchronous communication as well. And this is how you keep your modules really nicely defined, just as you would your services. So if we look at our services, these are the things in the back end that don't really touch the customer. They don't care like when other things have that information. So the order service will say, hey, there's an order. And the payment service will pick it up when it's ready and say, okay, I'm going to take payment. And the notification service will be like, oh, okay, the payment service has left a notification saying that the order is paid. I'm going to notify the customer that we've taken payment, okay? So it's all asynchronous. Everything does things in their own time. Now, a system like this can sometimes be referred to as event-driven or message-driven. There's a slight difference between these, but I'm not going to go into it. You can do some more research on that. But these are, because there are these events happening that things can subscribe to, okay? So putting it together, we now have the synchronous communication in the front to the customer, and then we have the asynchronous stuff at the back for all the machines to talk to each other, okay? And then the future services, now that we've got this system, we can start to scale up. Again, the things that talk to customers, so admin site, your administrators, the people running the business, their customers, their clients, their people of some sort, and they are going to have a look, and maybe they're using gRPC. And then the people in the kitchen, well, they want live stuff. They want to see those orders coming in quick, so maybe they're using SignalR over WebSockets. But the kitchen service behind it, that's just going to go and fetch things asynchronously, because it's a machine getting information from machines. So this is what we could look like in time. And because of this architecture, we're able to add in services without going and necessarily modifying any of the other modules, okay? So now we're sort of adhering to the open-close principle. So we're getting this really nice, well-structured, resilient architecture. All right, so now, because I'm on my computer and it's all happy, we can have a demo. So I'm going to show you a very quick demo. I should have swapped those around. I think this is an older version because I didn't have the best internet. But this is what I'm going to show you. So if you think about the order coming in, that's going to be HTTP. And then the order service is going to publish a message, because it's the producer, to our RabbitMQ topic exchange. And then our kitchen service is listening for those messages to be published. So we've got these routing keys. You can have wildcards in those as well. So you can have lots of different services listening for the same routing key or a variation on the routing key or just part of it. And then the order will send it to the browser via the kitchen UI. So, okay, I didn't really want it to do that, but that's fine. At the moment, I have RabbitMQ running in Docker. I'm going to zoom that in a little bit, because I had to restart. We had all the trauma. I haven't got everything as I like, but it's all good. We can manage. No, come back here. There we go, 2 fingers and up. So this is a .NET... There we go, I can, no, there we go. Zooming, yay, okay. So I have, let's get in the right project, those applications. I have the kitchen service, the order service, the RabbitMQ. Let me just see if I can make this bigger quickly. No, I didn't want that. Apologies for this. Can you make this? Right, it's zoom in, plus and equals. I thought that was, okay, I tried. All right, so the code will be bigger. Let's start with what we have with our RabbitMQ. It needs very few things, and I've done something really bad here, okay? I have a shared project, okay? This is not good. This is for the purposes of this demo. Do you see here I have the order service, that's one module, the kitchen service, another module, and they both need and depend on the RabbitMQ project. Okay, that is not loosely coupled, okay? If I change something in the RabbitMQ, I'm not going to have to change both of those projects, okay? So I've done this for convenience and for demonstration purposes. If you are doing something as .NET developers, we like to abstract things out into other layers and have common projects. You know the old where you'd layer your projects, you'd have like my project name .common, and there'd be a class library. Well, you don't really want to do that in microservices because now you've created a dependency. So this could be a NuGet package that you have, that you're a private NuGet, or you would just have this code repeated in both projects. We don't mind breaking the dry or don't repeat yourself rule in microservices. In fact, it's very important to repeat yourself, okay? Because we don't want that tight coupling. All right, so in here I have RabbitMQ settings. These are things that I'm setting in app settings that we need. Host name is where my RabbitMQ lives. Exchange name, so we're going to use something called a topic, and that's a pub/sub type pattern. And then, or that's the exchange type, sorry, and the exchange name is the common name I'm going to give it. And then what I've done here is I've got some iService collections just to make this a little bit easier. And this is a way of setting up RabbitMQ so that it will dispose of itself. So we have iDisposable down here. I won't go into this. I have a blog post on this that goes through it in great detail. And it does all the disposal for you, okay? So that's that. It's going to set up the connection. But that's an implementation detail. So both of these projects implement that. So if I go down to the order service, which is our producer, and I go into our program file, you can see up here, I'm using that setup RabbitMQ extension that I created, and I'm passing in the configuration to it. And that's all I need to do to set up the RabbitMQ. And then over here, I have a Rabbit sender. This is my producer. So I get the settings in, and I set up the channel, the communication channel, and then I have this nice generic function where I can pass in my message. I serialize it, I encode it, and then I publish it to the topic exchange. So you can see that we have the key, and this is the most basic implementation, okay? So that's going to send a message, and then that will live on the queue until something consumes it. So if we go over to the consumer, our kitchen service, again, I've got the setup, the RabbitMQ connections here. And then I actually have this as a long-running service. It's going to be listening all the time my application is running, because otherwise it's not asynchronous if it's not listening. So we need that as a hosted service. So if we go and have a look at this, you can see that we connect it. The hub is to do with signal R, so you can ignore that. It starts, it stops, and it does stuff. So it's just going to be listening. We need to bind it to the queue that it's listening to and tell it which key to listen out for, okay? So you can have this running, and depending on the key it gets, it can do different things. And this one is just going to take that order in, it's going to deserialize it, decode it, all of that, and then publish it to Signal R. So let's go and run it. So let's run the kitchen service, and then once that's done, we'll run the order service. And I need to find where the browser is. Oh, yeah, that's here. Oh, look, they're already started for us. Fantastic. Okay, don't be... How do I get out of this? I tell you, can you just, like, maximize without hiding the top bar? There we go. Okay. So RabbitMQ has a management thing. And if we go in here and have a look at exchanges, we can see the one that I just started and registered, waffle messaging. Now, it got that from our consumer that went and said, hey, I've got a topic exchange that I want to use, and that's called waffle messaging. So we can see that. If I click in here, we can see there's nothing going on. All right? So I just wanted to show you that first. Now, this is my API call for the order, and this is set up just to autofill it. So I'm going to execute this, run it, and oh, look, we've got an order. Okay, you saw a moment ago that that was blank. Let's just do that again. And oh, there's another one. So you believe that this is actually going through RabbitMQ. Look, there they are. You see, we've now got a graph, and they're pinging. So now we've got that communication with minimal amount of code. Now, there's a lot more that you need to do when you set up RabbitMQ to make it resilient, and if things go wrong, and how to manage those queues, but that's beyond the scope of this talk. But just to give you an idea that it's pretty straightforward to get started with this and start learning. All right, so let's go back to the code. Not the code, the slides. Hurrah, they're working still. Data. So this is a really big bone of contention with monolithic developers moving to microservices, okay? So this is probably what you have. Well, we know we've got this. And you have a big old bucket of data, don't you? Because in your monolithic application, you just have one database. Maybe you have a little bit more, but you generally will have one database. And you, as a monolithic developer, will cling to it as it's my data, it's all there, it's my big bucket of data, I don't want to do anything with it. So what does that mean in our microservices? Well, if you have just one database, we've broken our rule. We're coupling everything, okay? And we don't want to do that because, remember, we do not want to be in the top left-hand corner, and you will be if you keep one database, okay? And because this is what will happen. You will have a big ball of mud. Now, why is that? Have I got... No, let's go back. Okay. I want you just to admire this big ball of mud. That will be your distributed big ball of mud. Let's imagine we've got our two services, and they are sharing a database. You want to update the model on service A, and then you're like, okay, I'm going to do a migration to my SQL database. You do that. Now you've changed your model. What about service B? It's like, whoa, That's not the model I'm expecting. So now you have to go and update service B as well. And now you can't just update service A and deploy it. You have to update service B and deploy it. And you don't know what else you've broken in service B. And now you're like, well, I've got to deploy both of these. And what if you've got more services on the same database because you have that big old bucket of data? You have now successfully created your big ball of mud, okay? That's distributed, yay! No. So you need a database per service. This is not a rule you can break, okay? I just want that to sink in. You must not break this rule. I'm not big on rules. This is one I will stand on my hill and I will die on it that you will not break this rule, okay? I cannot stress this enough. So the beauties of having multiple databases, okay, and a database per service, not only will you not have a distributed big ball of mud for that reason, you can have it for other reasons, is that you can pick the data type of data store that suits your service. So maybe you'll have table storage and it's cheap and cheerful and scalable. Maybe you want a big, heavyweight relational data with lots of redundancy for your order service, or maybe you want to have a highly scalable document DB. You can choose the database or the data store that suits your application perfectly. So it comes with a lot of benefits, not just the fact that you won't have this big, horrible mess. Now, lots of people ask about eventual consistency. This is a really big, complicated topic that you need to be aware of, because if you've got asynchronous applications with multiple data stores, how do you get them to match? And that's where eventual consistency comes in. Now, in theory, this is like milliseconds, okay? It could be a little bit longer, but at one point, if everything stopped, all of your different data stores will be consistent with each other. Now, there's lots that can go wrong with that. There's lots of fail-safes that you need to put in there. This almost trivializes how complicated this is, but it's something that you need to be aware of, and again, that's a whole big section on its own. But it's something that you need to know and you'll need to research. So decomposition again, we're always going to be decomposing things. Now, this is how you decompose your data. Well, there's two ways. Data first. So I'd say this is probably the harder way, because if you're looking at your data, it's going to be harder to tease that data apart. You have to denormalize it a lot. But in the long run, this might be the easier way, because you'll soon realize if you can't do it a certain way, okay? And then that will influence how you structure your code. So if you think you're going to have problems with your data, decomposing your data, start with data first. The other way is code first, and you may want to go in this because, you know, we're developers, we feel more comfortable with code than data. But you could go and carve off your module and then discover that, well, actually, I can't get my data out of the database that way, and now you have to either throw that work away in the code or go back and modify it. So if you know that you can easily carve up your data, you can go code first. If you think your data is going to be really tricky, go data first, okay? So you just need to go through, analyze what you want to achieve, and then make the best decision. Security, yay! I can see you're all groaning inside. Don't worry, we're not going to stay in this section for long. Security and me don't get on. The number of live streams I've done where I've tried to do something with security and I end up like, I can't, I have to quit the stream. I've been here 8 hours and everyone's going, oh, no, this and that, and none of us know what we're doing, okay? So we're just going to cover this lightly. There's two things. You have machine to machine. So this is without a user. Now you've got your back-end services and now you've got your client. How do you know that your client is actually your client? So this application that's requesting information from your back-end service, you don't want that just free for all. Anyone can come and get to your API. So you need something called machine-to-machine. And these are where your machines will authenticate with each other without a user having to log in. So you don't want to go up to your online ordering site and say, oh, really fancy a taco. What type of tacos do they have? What? I need to create an account before I can see what food is available. You don't want that, okay? So you need this machine-to-machine. Now, if you want to come and order the food, you need some people. So you can now do your traditional user authorizing and authenticating via a sign-in, an account setup, or whatever you need to do, okay? So you'll have these two. You have options, so you can have cookie, token and claims, an identity account manager. That's not the right identity. I always have IAM. I can never remember what it is. I have this block. You know what I'm talking about, like Azure AD and Okta and things, okay? It's an identity something. Access management. Thank you. That's the A is always, I always forget. And but the one thing I want to say is don't roll your own. I have seen people on live streams rolling their own. Yay, we're going to put algorithms in here and, all of this type of stuff. And I'm like, no. Leave this to people who have PhDs in how to write this and make it as secure as possible and keep updating it for the latest threats. Okay, do not roll your own. Okay, now API gateway. I say you may have already experienced these. A lot of cloud services come with these as part of the service. So what is this? Well, this is that single point of entry to your applications, okay? It can be called a reverse proxy as well. And do I have a nice diagram? I do. Okay, so if we don't have a gateway, if you've got a client, a web client, or an app, if they want information from your service, they're going to have to go to that service. Now, remember, we have to secure these. So now you're going to have to authenticate with each of these services. You're going to have to do all of these things. And that sounds like a headache I don't want. I don't want to be doing multiple security thingies. So we have an API gateway. And so this allows that one point of entry, and that is also a single point of failure, so you need to make sure that you're handling that. Remember, I said this was going to be complex, and you had to be sure you wanted to go down this path. And then now, the API gateway can be a centralized access point where all of your identity and security is all there and dealt with, rather than in your services. Now, that doesn't mean that your services should be HTTP and not HTTPS. They should still be HTTPS. Don't get lazy. You can also have something called a BFF, not best friends forever, but backend for front end, where you have a different gateway for a different front end. So, for example, my banking app for my bank is limited on my mobile phone. I can't get statements from more than 6 months ago. If I go onto the web client, I can get statements for a much longer time. Now, that's probably because they have a BFF. So they'll have one API for the mobile app that gives me just 6 months of data, has different APIs to the BFF for the web client. So you can get nice control over different things by having different APIs, okay? API gateways, I should say. All right, service discovery, or sometimes called a service registry. You may or may not have come across one of these, but if you've got lots of food trucks, and food trucks are mobile, they drive around, what if you don't know where they are? How do you find them? You need to know where they are to be able to go and get your lunch from them, don't you? So that is what a service discovery does, or a discovery client. So the beauty of this is that your applications self-register. Yay, you don't have to do anything. The code you put into them means that they will go and register themselves with the client. Now, the discovery client. Now, your web client or another service comes along and says, oh, I'd really like to go to this particular service. And there's 3 or multiple instances of these services. So the discovery client will be like, okay, well, all of these instances, because it's scaled, have registered with me. I'm just going to load balance or randomly pick whatever algorithm you set. You have control over that. Pick one and return the IP address, the location of that particular instance. It gives it to the client, and the client can go and get its information from it, okay? So this is a way of having all of those instances self-register and be located. There are some common service discovery options. You can have Netflix OSS. They have Eureka. Now, there's 2 versions of Eureka. Netflix have abandoned one, and then they've left the other one as open source, and that's what other people can use, okay? It's pretty cool. It's really lightweight. I've not used Zookeeper. I have used Console. That's a good one. And there are so many more. And they can all do different things. They have all different features. So choose one that works for you. But I am going to show you still using Netflix. I'll have to correct that. And I'm going to show you how to use that. So let's come out of this. And I have Netflix Eureka running in Docker. And you can see this is the web UI for it. And nothing is registered, okay? So we can see instances currently registered with Eureka, none. Let's change that. So let me just close these windows down. And I have in here 2 applications, okay? You are not allowed to groan at me for these jokes you are about to see. They're not mine. They come from an API, okay? They're nothing to do with me. All right, so we have the dad joke API. And in this, if I go and show you in the CS proj, I have this thing called steeltoe.discovery.eureka. Now, steeltoe is a port of Spring Cloud Boot, and it allows you to connect to service discoveries of your choice. You can change it without really having to change your code, so they're an abstraction. And it's just really easy to use. So I thought I'd show you this. So we just need the NuGet package, and then in our program, we just add discovery client to our services. There's a lot of configuration that you can have. You don't actually need any configuration. It has a lot of defaults, but I wanted to show you this basic bit here. So we've got our Eureka client, and then this is going to my local instance. And then we've got these 2 things. Should register with Eureka. That means I'm going to put my address in the phone book, okay? So that's your self-registration for your applications. That's the yay bit. And then should fetch registry. Do you want to allow the application to go to the registry and get those addresses? Okay, so you can control it a lot with that. And there's so much more that you can do. But all I needed was really, not that one, this one, just that one line. Okay, so I am going to create 2 instances of the dad joke API. So if we come over here, there we go. I'm going to create one on 5005, and then one, that must be 5006. Let's go. All right. So now, if we go back to our Eureka console, you can see that I have this application. This gets it from the project name. In your configuration, you can change this. It's called the dad joke API. And then it tells you, well, that's on localhost dad joke API 5005 and 5006. So my applications have self-registered, so yay for that. Okay, so that's the registration, but what about the consumption? So if we go here, again, I've got the NuGet package, and in here I have the discovery client added, but I also have this hosted service. It doesn't need to be a hosted service, that's just what I've chosen to do. because I'm going to bombard you with jokes. Now, because the discovery client was added to our iService collection, it's now available from our IOC container via dependency injection. So I've got this discovery client. It is the interface that is available. So when I inject it into my constructor, I do need to cast it as a discovery client. It's not the nicest code, I'll give you that, because we've got the red squiggle, because we don't like casting, but that's the way it has to be done. That's the way it is. Sorry. Not sorry. That's it. It's not my fault. I didn't write it. So we've got that. Now we can go via that API and get all the applications and say, get the registered applications. So we can go and fetch all of those. And then what we're going to do is just loop through them. And I can get the different ones, and we're going to print some stuff on the screen. Okay, so that's it. You've now got all of those applications. You could go and fetch them by name and things like that, because we know what the name of each project would be. You could set that in external configurations, so it's shared, so you can start to see how all these pieces start to come together. So let's go and get ready for some, oh no, I should have cleared that. Damn it. Don't look, avert your eyes. I don't want you to be, oh my God, why can't I can't get anything to clear. Okay, stop, I'll tell you when you can look. I just need .NET Run, don't I? Escape, Control C, okay, clear, that's what I wanted. Oh my God, okay, you can look again now. Oh, all right, let's make this bigger. .NET Run, dun, 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 the suspense. All right, so you can see we've got two instances. We've got 5006, 5005, and then it's randomly going to get a joke from each instance. So we've got 5006, 5005, 5006. It's alternating at the moment. 5006 again. So now you can see somebody stole my Microsoft Office and they're going to pay. You have my word. Oh, my goodness. Okay, we could go for hours watching these. But you can see now how you can really quickly start getting into those different scaled instances. Okay, I'm going to stop the torture, okay? Right, so that's a really quick example of how you can do that. Let's just fix that. Quickly done. Whoops. Okay, so let's go. We're almost at time, but I'm going to steal a few minutes because of the tech issues at the beginning. So I always think that's quite fun to go and play because it's a fun thing to do, to see all those instances just registering like that. I love it when stuff sorts itself out and I don't actually have to write that many lines of code. Now, actually writing code, things to bear in mind is plan the scope of each project. So really, before you start carving things up, look at what that high cohesion area is. Plan it, think of the scope. Remember, it can be big. We want those big chunks before we start decomposing it further. Plan the right solution for each project. Now, you'll hear about microservices. Yay, we can write them in whatever language we like. As long as you've got the skills, you can, but don't, if you're all .NET developers, don't go and write it in, I don't know, Go, because that's the fastest, most efficient. You know, that may be the truth, but you don't have the expertise in-house to write it. Don't do it, okay? So plan the right solution that includes data, layer in the complexity, small implementations, create a service. Don't worry about securing it first. Can it give all the information? Now add security. And be flexible. If you need to make something a little bit bigger in scope or smaller in scope, do it. And just try it and be flexible. This is going to be a steep curve of a learning process. So, just go with it. Be kind to each other. It's going to be tough. Now, other stuff, because this topic is vast. Deployment, I'm not a DevOps specialist. I have been forced to do Kubernetes. I even had a live stream with Kelsey Hightower himself coaching me through his whole workshop, and I was still like, I don't get it, Kelsey, I don't know. So, that's a whole nother thing, okay? Monitoring, I cannot stress how important monitoring is. There's whole workshops on monitoring. It's really complex, but if you're not monitoring, you don't know the health of your application. You don't know when it's needing to scale. You don't know if it's too big, too small, doing this, doing a little fan dance. You need to monitor all the things. And then availability, scaling, and load balancing. But you can only understand that if you're monitoring, okay? There is a whole lot of other things in there, but this is like an introduction, a guide, trying to get you on your way. So some resources that you can go look at. Steel Toe, it does have some really cool management endpoints where you can get health checks and things in there. Dapper 1P, no E, is, I don't personally like it, but you might. I've played with it and I didn't get on with it. But a lot of people find it amazing and it's really cool. So you go and play with it, make your own decisions. Project Tie, I think that's stagnated a little bit. That was being done in Microsoft. It's an open source project, you can go and do that. YARP, yet another reverse proxy, is my favorite API gateway. I've got blogs on that, videos on that as well. It's really lovely to implement and configure. I just really enjoyed working with it if you want an API gateway. It's just good. It's just, when something is good, it's well documented, easy to use, why not use it? So if you want more stuff, you can come find me on YouTube. I make weird, quirky, often food-related videos, so you can come in and check that out. And follow me there. And with that, I'd just like to say a big thank you for sticking with us through the technical stuff. I will be around for today if you have questions or want to ask me anything. You can find everything on layla.dev. My DMs are open on Twitter. You can just come and find me. And so thank you very much.